Greetings everyone, welcome to our YouTube channel. In this video series, we will talk about polynomials. First, we will start with the standard form of polynomials. As you can see, this form is the standard form of polynomials. You don't have to memorize these, but you need to know some terms in order to solve questions about polynomials. So let's start with the terms. So each part of this polynomial is called as a term. This part, an to the power, an x to the power of n, an minus 1, x to the power of n minus 1. These parts, they are called as a term. So here we have our coefficients. They are an minus 1, a1, a0. These are all our coefficients. These coefficients can be any number. They can be positive, they can be negative, they can be real numbers, okay? But we have to be careful with the exponents here. Why? Because these exponents have to be equal or greater than 0. They cannot be less than 0, okay? We have to be careful with this. And here we have degree. So here, degree is the biggest exponent in your function, which is here, as you can see, x to the power of n has the biggest exponent, because this one has n minus 1, n minus 2, it goes like that. So here n is our degree. And here we have leading coefficient. Leading coefficient is the number written in front of the variable with the largest exponent, okay? So here, as we said before, this is our largest exponent, which means here an is our leading coefficient. And we have here constant. Constant is a number which does not have any variable in front of it. So as you can see here, a0 is just a0. It doesn't have any x, y, z, right? It doesn't have any variable. So that's why we call this as a constant. Let's look at this example and we will understand better. So we have here 2x to the power of 2 plus 10x plus 8. Okay. Our terms. What are our terms? So terms are 2x to the power of 2, 10x, and 8, right? Because what was the term? Term is the each part of this polynomial. So let's write them down. We have 2x to the power of 2, we have 10x, and we have here 8, okay? Exponents. So here we have our exponent 2, we have here 1, right, because this is x to the power of 1, and we have here 0, x to the power of 0, which we don't see here, we don't have to put here because we already know that x to the power of 0 is equal to 1. As an exponent, we have to write it here. Okay, so coefficients, they are the numbers written in front of our variables. So here we have 2, we have 10, and we have here 8. Okay, let's look at our degree. What was the degree? Degree is the biggest exponent in our polynomial. So here, let's look at the exponents. We have 2, 1, and 0, right? Which one was the biggest? 2 is the biggest, which means 2 is our degree of our polynomial. So here we write 2. And our leading coefficient is the number written in front of the variable with the largest exponent, which means 2 is our leading coefficients. Let's continue with other examples. In this example, we have px is equal to x to the power of n plus 1 minus 3x to the power of 5 minus n plus 2x minus 9. Which values of n can make this expression a polynomial? So in order to make this expression a polynomial, these exponents, they have to be equal to or greater than 0, right? So which means n plus 1 has to be equal to or greater than 0. It's also same for 5 minus n has to be equal to or greater than 0. So from here we get n is equal to or greater than -1, and from here we get 5 is greater than or equal to n. When we combine these two together, we get -1 is less than or equal to n, and n is less than or equal to 5, right? We get this, which means n can be -1, 0, 1, 2, 3, 4, and 5. So these values of n can make this expression a polynomial. Let's look at our second example. Decide whether the function is a polynomial. Okay, let's look at these functions. First one. First of all, you have to look at the exponents, okay? You have to look them and see if they are greater than or equal to 0. Okay, let's look at these exponents. We have here 5x to the power of 3. Okay, this is fine. We have here square root of 2, x to the power of 2. This is also fine. We have here 1. This is also fine. And we have here 1 over 3. This is our constant term. So we can say that this function is a polynomial since their exponents are greater than 0. Let's look at the second one. We have here x to the power of 6. This is fine. We have here 5 over x to the power of 4. This, we can write this as a 5x to the power of -4, right? When you put this up. So which means here we have -4 as an exponent, which makes this expression, is not a polynomial. Also here we have -1. This is okay because it's 1, but here also we have -1. This also makes this expression is not a polynomial. Now we will continue with the names of polynomial functions. So some polynomials have special names based on their degree and the number of terms they have. For example, here, when its degree is 0, like here, because we have only 5, and as I said before, actually we have here 0 as an exponent, but we don't have to write it, right? So here we have actually 5x to the power of 0, which is this, its degree is 0. It's called as a constant. Okay, when its degree is 1, it's called linear. Here we have x plus 4, so its degree is 1, so it's called as a linear polynomial function. When its degree is 2, it's called quadratic. So here we have 4x to the power of 2, its degree is 2, which means its name is quadratic polynomial function. When it has a degree of 3, it's called cubic function, and here we have 4x to the power of 3 minus 2x to the power of 2 plus 4, right? Degree, what was the degree? Once again, degree is the biggest exponent in our function, so here is the 3 is our biggest exponent. That's why it's called as a cubic polynomial function. When its degree is 4, we call this as a quartic polynomial function. Here we have 2x to the power of 4 plus 5x to the power of 2, right? So which one is the biggest? This one, 4 is the biggest. So our degree is 4, which is called as a quartic polynomial function. And the last one, we have 5. Here our example is minus x to the power of 5 plus 4x to the power of 2 plus 2x plus 1. So it's called as a quintic polynomial function. When it comes to number of terms, for example, here we have only one term, right? What was the term? Term is each part of the polynomial. So here we have only 5, which means number of terms of this polynomial is only 1. We call it as a monomial. So here we have 2 terms, right? We have x and we have 4, which makes it binomial. Here also we have only 1, 4x to the power of 2, which makes it monomial. And here we have 1, 2, and 3 terms, which makes it trinomial polynomial function. And here we have 2x to the power of 4 plus 5x to the power of 2. We have two terms, right? So it's called binomial. And here we have 1, 2, 3, and 4 terms, which makes it polynomial of 4 terms. When it is more than 4, we call this just a polynomial.